Predicting results of complex loading can be a real challenge. But if we consider one load at a time, often the structure is much easier to analyze. Under common conditions, the effect of complex loading is the same as adding up the effects of each load considered separately. For example, the effects of this loading are the same as considering the effect of just the point load, plus the effect of just the distributed load, plus the effect of just the moment. We call this the principle of superposition. When I say effects, I mean all effects. We can find reactions this way, internal forces, and deformations all by superimposing the individual results. I did say under common conditions, but what does that mean? The material must remain linear elastic for superposition to be valid. That means the load deformation response of the structure must remain linear. So if we apply force F1, it will cause deformation delta 1, or if we apply force 2, it will cause deformation delta 2. If the material remains linear elastic, then applying loads F1 and F2 causes a deformation delta 1 plus delta 2. If the material does not remain linear elastic, the load displacement curve typically softens, which means it bends over to the right. In this case, applying loads F1 and F2 causes a deformation bigger than the sum of the individual deformations. The other requirement is that second-order effects must be small. Second-order effects are the effect of the load on the deformed shape. For example, consider an elevated water tank. There's a large gravity load at the top. Then consider what happens when there is a large lateral load due to wind. First-order effects are based on the undeformed shape. In this case, the moment at the base of the tower is the lateral load F times the height h. But that tower is going to deflect under the lateral load. It is going to move to the right a distance delta. If we calculate the moment at the base of the tower now, we see that the moment is larger. There is still the effect of the lateral load F times h, but there is also the effect of the weight of the tank P times delta. That P delta effect is only captured when we consider the effect of the loads on the deformed shape. It is a second-order effect. In order to apply superposition, we are ignoring all second-order effects. Fortunately, for most structures, the second-order effects are negligible.